If this works the way the internet says it does, TIG welding's in trouble. Gas welding's in trouble.
It came. It finally
Works the way the
came.
internet says it does, TIG
The
welding's in
big
trouble.
one.
Gas welding's in trouble.
It finally
Works the way the
came.
internet says it does,
Danger.
TIG
The
welding's
big
in trouble.
one.
Gas welding's in
Laser.
trouble.
Invisible laser finally
Radiation.
came.
Danger.
The
welding,
big
class
one.
Gas welding tool. I'm excited to try this out.
Invisible laser
Radiation.
radiation.
Long
The
welding,
big
class
one.
Pretty cool. I'm excited to try this out.
Invisible laser
Yep.
radiation.
Long
The
welding,
big
class
one.
Pretty cool. I'm excited to try this out.
Invisible laser
Gas welding, long lighter, a laser cleaner, and a laser
Invisible laser.
Is it all high? The future of restoration. The most versatile laser welding, welding, cutting, cleaning, and rust removal. I reckon this is awesome because, like on the Porsche project, versatile. Not only do we have cutting, sheet metal, cleaning, and rust removal. Fresh, and we can this is awesome because exactly right. Like on the Porsche project, versatile. Not only do we have cutting, sheet metal, cleaning, and rust removal. Fresh, and this is awesome because this is going to be great. Like on the Porsche project, versatile. Not only do we have cutting, sheet metal, cleaning, and rust removal. Fresh, and this is awesome because this is going to be great. Like on the Porsche project, versatile. Not only do we have cutting, sheet metal, cleaning, and rust removal. Fresh, and this is awesome.
Small setup is a relatively
My understanding, laser welders predominantly been used for manufacturing, like factories down assembly lines, program robot. My understanding, laser welders predominantly been used for manufacturing. This evolved into portable assembly lines, program robot. My understanding, laser welders predominantly been used for manufacturing. This evolved into portable lines, program robot. My understanding, laser welders predominantly been used for manufacturing. This evolved into portable lines, program robot. My understanding, laser welders predominantly been used for manufacturing. This evolved into portable this could quite well That's a little sample piece. That's phenomenal. They're 1.5 mil wide. That's ridiculous. And I'm assuming that this edge here, that's an example of the cut edge that the tool does. So as we do the right thing here, let's read the book. The whole first chapter is completely on safety stuff. Fresh bottle. I think I'll be getting a new regulator as well.
What's wrong with that one?
I think I'll be getting a new regulator as well. Got this thing on the trolley. Just went down the local local tool. I think I'll be getting a new regulator as well. Got this thing on the trolley. Just went down the local local tool. I think I'll be getting a new regulator as well. Got this thing on the trolley. I just had to duck out, grab an extension cord, 15 amp, single phase power cord for this unit. So it's not a 3-phase thing. We're plugged in, about to switch it on, reading through some information. Really think good to point out, your standard welding helmet's not going to cut it. You need to have a welding helmet that's specifically suited for laser. So we've got one of those, Xlaserlabs. We're happy to supply us with one of those to go for their machine. So I got no idea technically why we need this, but documentation says laser specific mask. So we got that. On the topic of safety, probably a real good thing to point out is this is pretty serious stuff. We all just like, oh, let's just get into it. I'm so keen to get in here and weld this stuff. But this is what's called a class 4 laser. And we did a bit of reading. Class 4 lasers, pretty serious stuff. This is what's called a class 4 laser. Really, we need to be in a did a bit of reading. Class 4 lasers, pretty serious stuff. This is what's called a class 4 really, we need to be in a did a bit of reading. Class 4 lasers, pretty serious stuff. Hopefully, we don't need that on this video, but maybe we'll have to wait and see. Probably the biggest thing though, the rules and regulations, they're going to change depending on where you are around the world, your state, your country. It's all different. So always just check up on the safety aspect, what you need to do. And remember, this is a laser beam. Like, this thing shoots lasers. So if we are welding off the bench and we accidentally pass off the bench and go across our foot, that laser's going to hit our foot. We're actually shooting up here and someone's upstairs, laser's going to go hit them. So I think that's the reason why it has to be in a purpose-built or self-contained controlled environment. So this is where we're at. We've got our purpose-built wall here behind us to protect us. We're just going to get into it and get some welding done. So let's go. Let's fire it up. What do we got? Power at the back, pretty standard. Ooh, fancy key, ignition on, welding, cutting and cleaning. Cleaning's going to be fun, especially for what we're doing, restoration work. Man, that would save so much time. Cleaning rusty steel, old paint and crud like that. especially where you have parts you can't rip off the car. Pretty self-explanatory. Welding, confirm. I have no idea where to start.
So you've got to hit that button in the middle as the on. So this essentially is like the third on, and then you're happy that
The safety
you've
warning.
got your safety warning going on.
Fantastic.
And now we're live.
Before we weld, we should go through some of our samples here we've laid out. We've cut up some sheet. I got 0.95 mild steel, cold rolled panel steel. It's pretty much what we use predominantly. Sheet metal, especially in restoration. So we're going to do pretty much today. We're just going to do this. We're not going to get into the heavy stuff. Real world scenario. You know, we've got rusty old car, nice clean fabricated piece. We experiment with this with some cleaning and some welding. I might dice this in half and do an uncleaned and a cleaned, or this thing cleans itself, laser cleaner. So what would happen if this was in the car, rusty old stuff, put your new piece, you want to do one pass with laser cleaning, second pass with weld. That would be amazing. That would be game changer. So we've got that. Fabricated piece that's oily, we can use that. Fabricated piece that's rusty, so we can play around with that. So this rust is not too old. That's only about 3-4 months worth of rust. That leads us into the next thing where we've got real world hardcore rust. So here we have 60-year-old rust on that.
So that's a bit of Porsche off cut.
Bit of Porsche, bit of 1963 Porsche. Over here I want to experiment. I've got some tinning paste. So this was leaded and then it's tinned. We've blown the lead off and there's some tin there. And old paint, sound dead now. So this will be hardcore for the cleaning side of things. That's going to be awesome. Real world, if you're working in a car and you're trying to clean this and you're trying to get into a corner, couldn't get in there. Let's see what this laser does. Anyway, we've got a few samples. We're going to work through that.
Safety first.
Safety first. Bang. Click to enter the light gate open, light gate open to normal light. Hang on, I got to read that again. Okay,
Go
ready?
again.
Click. So picture of the power button. Let me start again. This is, man, I got to try and read this right. Click to enter the light gate open, light gate open to normal light. Is it just
of
me,
course.
or does that?
No, that's simple. I feel like
Moving on?
these guys need to revise that sentence.
Oh, I don't know. Maybe we might get into it. We might find out what that
Might
means.
make sense.
Not now. Not yet. Click the rectangle with the bar of golds and sus to enter the preset process welding package. Select the material and the corresponding thickness. The system automatically sets the corresponding welding parameters. That's the one we wanted. That's pretty cool.
Isn't it?
Oh, having those presets.
Knowing, you just have to know what you're playing with.
Yep. Here's a good one. This one's important for us. You got the gas before laser, the setup time for blowing gas in advance, and the gas after laser. If you guys, when you set up your sheet metal and you set it up and you spent ages making these parts, you butt them up really nice and you run through and you do your tacks, it's always really good to run excess gas after the tack, not only to cool it, but to stop the impurities from the atmosphere getting into your tack as it's cooling. So there's always like the, I don't know what the settings are on the TIG, but I always run, 3, 4, 5 seconds of extra gas after the weld. So on this machine, in those parameter screen we just showed, you can do that. You can do your gas pre and post weld, which is pretty cool. Yep, I reckon there's another page there of information. We can, yep, we read that one. Yep, we read that one and that one. And the next one. Now we can weld. About to do this weld. Put this earth clip on. We just noticed, I was about to put this, not an earth clip, safety. About to put this safety clip on, but we've got our steel welding bench. This is pretty light duty. I reckon this could be a little bit heavier perhaps, but anyway, we noticed if we just clamp this on our bench, we're set to go because the metal conducts electricity, so it's all going through. This little light just over here on the side, it goes from red to green. So that gives us more green to go. So what's the alarm light telling us?
That must have been the page that you skipped. Pete.
Here it is here. The heat band though, that penetration, well, let's check that out.
Is that
actually.
connected it underneath?
It's welded it to the steel.
Wow.
It's almost hotter. Look at that. It's hotter on the back side than the top side. That's amazing. That's brilliant. let's just try a spot weld. I've seen other dudes overlap and try and run a weld on the overlap on a car. You just don't need that type of weld. So what you do need is a spot weld. I want to just jump ahead here and go straight into doing a spot weld. I'm going to keep it off my bench so I don't weld it to my bench.
Yeah, you can hear the gas. Yeah, it's flashing on and off.
You can hear it ramp in and ramp out. Hear the power ramping. I might turn the wire speed down. Wire feeding configuration. Oh, it can work. You can do it with gloves. All right.
Next.
I might try going forward instead of backward. That's really hard because the wires, you're working against the wire. That one there, look at that one. That's that good looking one. Let's put that aside for later. We'll do some, I think there's a...
Looks promising though,
Well,
doesn't
Pete
it?
was telling me there's a technical way to test a spot weld or tear apart. You chuck it in the vise and let's find out. Let's put that aside. We'll come back to that. Looks promising for some spot welds though, without a crazy spot weld machine where you have to get to both single-sided spot welds. Because you don't need the arms to come and clamp. You can just put your job on and bang bang.
Which seems to be one of the biggest problems. Like we've hit that with the Porsche trying to get around where the dash and everything is. Even with the huge arms on it, you're still limited.
I reckon that's a thing for later. We're going to play around with the wire speed and the gas and try and optimise the spot weld. A tack. That's the next thing we're always doing is tacking two bits together and then welding them. We're going to try and tack these together.
All right, tack time.
Yeah. So normally when you weld across your body, but this machine seems to work better this way. Don't think that worked. That looks like it's tacked. Super neat. That is ridiculous. You know how much faster that is than trying to do that with the TIG? Once we get that wire feed dialed in.
We need to sort of get the temp gauge on it and see what...
Look. Have you been recording that whole time?
Yeah.
That's like...
It's not even hot, not even warm.
50 degrees, even, not even.
So we need to do a side-by-side comparison.
They feel pretty...
In a later video.
Well, we're going to do a second video.
Yeah.
So we're going to plan is, guys. You've seen 2-3 minutes ago. We just turned this thing on. We're going to do all this experiment. We're going to put this welder into action and do a second video follow up once we roll this in and implement it. But so far, this is looking so good. This is going to be such a great time saver. If we can tack like that tiny amount of heat so fast. Now we just got to figure out how to weld it. Maybe you just do it like that.
Just give a little wiggle at the end.
Look at that penetration. All the way, oh. Yeah. I'm going to do one more weld and try and planish that out. But that, seriously, first time laser welder right there. Over the tack and off the end of the job.
Not quite.
That's just teething issues. That's for us to figure out that. You can see there I was a bit fast in the middle there. Not quite enough penetration. Let's just try that little end bit. I'm going to try and planish it out on the dolly straight up. So I'm just trying to get that bit of shrink out of the center of the sheet. There's a little bit there, so I might just have to planish it slightly harder than I would have normally.
Not a lot of grinding required.
It's pretty impressive. Pretty impressive, that is. I think I'm in love. I'll put a close up on the screen, but no distortion, no grinding, no sparks, full penetration, except for that tiny bit, which was my fault. But the weld is just, that is magnificent. I can't wait to spend more time getting to know that. And those spot welds, they're going to be crazy. I'm going to sort them out. But let's move on to the next thing. Absolutely blown away with this welding. Man, I've got to mention, thanks to Xlaserlab for reaching out and putting a deal together. We partnered on this to learn more about it. And the whole goal of the video is to see if this thing's suitable for restoration. Is there value in this? Does it work? Does it solve a bunch of solutions? That's what we're working through. But this machine so far, on first impressions, this X1 Pro, potentially this could be a real game changer for restoration. But if you guys are interested in trying one of these, we've got an affiliate link in the description. You can go get one yourself. So check the link below, go check it out. We're going to continue and we're going to learn some more about these other settings. Next up, we got cutting. We just changed the tip. That's it so far. Just changed the tip, rearranged some stuff. We've got some scrap steel sitting here. We're just going to try and whip through this. So moving from left to right, we're just going to hit the cutting option. And I guess what? Confirm. Vertical cutting is strictly prohibited. Angled cutting is permissible. So I guess we just do angle to the side or angle in line. We'll figure that one out. Nice bit of warning, and it's changed all of our settings.
Chop, chop.
Okay, point and shoot, and this is where we need to be careful of all of our power cables. Might move over here a bit more. Power cables and toes. Let's give it a shot. That's nuts. It's
making a mess of the
look
floor.
what happens to the floor.
The floor literally
the
caught
floor.
on fire.
It's not too bad.
Yeah, okay.
It's not too bad. Man, if you had something flammable down on the floor and shot it, it would take off. More time. It cuts, like it cuts, if you had to cut a big chunk out, you know, it's not as neat as like a $500,000 laser, but it's 1/100th of the price.
You want to run it through the alloy for a laugh?
If that's gone through, it's actually neater than the thin steel. Yeah, it's hot.
You'd expect it to be hot. All right, cutting, done.
For high precision stuff, you're going to get a big laser to cut it. I think we've got more time. We're going to put more time in and learn these settings more. If you had some bracket you were making and you're on the fly and you didn't mind a little bit of cleanup, you could cut that out and get it cleaned up. It'd be still way faster than trying to do it with a grinder. Cleaning, confirm, and all it has done is changed all the settings. 8mm width, so that'd be interesting. 40% power. Okay. If I go further out, less powerful. It's actually melting the steel. Look at the heat. Wow. I wonder if you could use this to heat shrink. Do you reckon I've gone too aggressive? I go a bit lighter.
Finding that sweet spot, isn't it?
Yeah. You can just see
You can
there.
see it start to happen.
You know what though? That has cleaned the rust off though, where I was further out. But it got hot too. Paint, let's try old paint.
Have some crusty, rusty Porsche and see what happens there.
This is gonna get hot. Okay, here we go. How's the sound effect?
Yeah, it's full Star Wars, isn't it?
Yeah. Let's try, there's a seam there. Let's try and get that seam.
That's pretty good, isn't it?
Let's check the cleaning. Sorry, a little bit of paint here. I know sometimes these areas around window frames are difficult to get to around spot weld, so let's just try cleaning the paint in difficult to get to locations.
That does a pretty good job, you would say, wouldn't you?
Definitely cleans the paint off. That's a great job. Just hot. I think I wouldn't be doing that in the middle of a panel, the sheet metal, but around edges and corners. Let's have a look a little bit more up on that flange there.
Well, compared to alternative methods for that sort of location.
It's definitely faster and cleaner than any other way. Let's try the leads. There we go. You know what? This would be super effective for removing lead because you can put the heat exactly where you want it compared to a torch. Like a torch is a big flame, right? And it spreads out and blows it out everywhere. But if you want to go in and do a repair next to lead or clean it out in a delicate area, this would be a better option because it's so precise and controllable. Really impressed with this thing. The welding is 12 out of 10, 15 out of 10, just absolutely blown away. I'm so excited to use this as the welder on the build and implement this and learn more about it. The cleaning, we need to learn more about, get those settings dialed in, especially the cutting. I think it's gonna cut, it'll cut neat. It's up to us to learn these settings, but the welding, I'm blown away. There's one more thing, I think we could heat shrink. I really think we could use this to heat shrink. Learn more about this, we're gonna use it some more, get to know it, and we'll come back with more.
700. Right, Gemma's a bit angry.
We've spent all morning getting blown about. But we've been assessing all the jobs that we need to do in the future. So we've been measuring up for all the materials that we need to buy. So the rear roof, the rear deck, all the beams, the transom, the cabin sides, and by our math we need 40 sheets of marine ply. We need a lot of deck beams. We need 8 for down here, we need 12 for upstairs. We need loads of wood for like the transom bits. It's a very, very expensive list.
So you've sent out a few emails, haven't you, to try and get some plywood?
Yes. So while we're in the middle of sort of waiting for parts to come, waiting for weather to come, we've done a sort of winter job list. Do I need to stand back so I can fit it all in?
Yeah. Yeah, so there is lots of little jobs which we're sort of not neglected, but we rainy day jobs.
But they're not massive jobs to get your teeth into, they're just loads of little crappy bits. So let's go and start ticking little jobs off the list.
So first on the odd job list, we glued it, but we didn't put any fixings in it. This is the rudder block thing, plank, going to the stringer.
Now we have very different opinions on this, me and Simon, because my opinion is it doesn't need fixing. The original one was never fixed to the hull, so why are we fixing it to the hull?
What age did you start playing Lego?
Why do you want to fix it to the hull?
Because in the past, when these rudder blocks were stuck, the whole thing used to flex. Couldn't really portray that on camera, and then it actually triangulates the boat a bit more, doesn't it? And there's a bit of glue on it, but if we do have a big hit, I don't want this to move. Why not? The rest of the boat's fixed.
Okay. What do you think?
Bit early in the morning for painting for my liking, but
Not enough on there?
yeah. Strong now.
First job off the list. The next job on the list says to seal the rudder support block. Now this is another one that I don't agree with.
Seal it?
Yeah,
Okay.
that's what you put.
Why do you just disagree with me all the time?
Because
Have you noticed?
my thought on sealing all round the rudder block.
No, I didn't say seal it all.
Okay, well my fear is don't seal it all because if it leaks I'd rather seal it.
If it's gonna leak, it's gonna leak by now. It's a wooden boat.
I know.
They leak when they first go in, and they swell.
Yeah.
Right, Gemma.
But what's the benefit?
Everyone told Gemma that boats swell.
But what's the benefit of putting sealants all around it?
Let me show you. So, see this puddle up here?
Yeah.
Yeah? What's that?
From our leaky deck?
Yeah, leaky deck, yeah? So if it gets down here, and we don't want it to go down this gap here.
Oh, so you just mean seal the top?
Yes!
Oh, I thought you meant seal all the way
Seawater
round
doesn't
it.
come from here. Comes from up down there.
Well, when
Water goes uphill.
we spoke about it last time, you made it sound like we were sealing all down that gap as well there.
No, so I just wanted to like seal along here.
Okay.
Alright? Simple.
Well, I'm fine with that, but that's not how he explained it last time.
So the question is now, is she going to spit on her finger and wipe it, or just leave it like that? Yep. So I'm doing a job that isn't actually on the list. Didn't quite make the list, but this block here was never actually bolted down, because if you remember, we sort of a bit rushed towards the end of the rudder episode, but put some bolts in it. Lovely little acorn nuts. Check them out. It took me ages to find them. Knew I had them there. Let's find the hole, Simon.
So I need to write it on the list just so I've got the satisfaction of ticking it off.
Yeah, go on then. Right, so the next thing on the list is seal the A-bracket blocks of wood. They're basically what the prop shafts go on. So the prop shafts come along and then they're carried by an A-bracket and then mounted to the hull. But they look a bit, I'm going to call them furry. They're not rotten, big chunks of wood, but they're a bit furry on the top. My intention is take these plates off, sand it all, then epoxy them, and it'll like seal them, won't it? Stop them being so furry. But we're actually floating later, so we don't really want to undo these bolts, and then the props fall off, do we?
So the stainless steel bolts go all the way through to the outside. That block as well, by the way, we're not replacing that one because that one is fine.
Yeah, it's been replaced at some point. I think it was replaced in the 80s, but it's in perfectly good condition. And
that is also fitted with stainless steel bolts, like we did to the one over there.
Yeah, I'm not convinced because there's no video evidence of they did it the same way as we did by welding our heads on it. But they have got a hex head on the back, so maybe they ordered some super long bolts, or what I have seen is people welding them together in the past. So when we come out of the water at some point, I wanted to take all these bolts out and inspect them, but there was a lot of people saying you can't use stainless steel on a boat or below the waterline or something like that, which we did a tiny bit of research, and yeah, there is some talk out there, but
they've been in,
yeah, since 1980, I'm guessing it was in the 80s they replaced them, so what's that, 46 years now. Modern boats, I mean, our Butari's got stainless fixings, hold all of the P brackets on underneath, all the rudder gears, he's got stainless bolts, they're all perfect. So
the actual prop shafts?
The actual prop shafts, I think they're a slightly different stainless, they're a duplex stainless. It's still stainless. So I think stainless is the way forward. I know originally the boat didn't have stainless, it was bronze, but that's failed, isn't it? So I don't know. I don't disagree, but I don't actually agree with that, but I'm sure there'll be lots of people typing away now going, oh, it's dangerous, you may as well use Screwfix cheap threaded rod.
But it is something that we can change when we are on the hard, because you know how difficult it was to get them bolts in. So things like that can be changed when we are out the water.
Right, so next on the list is web frame crack. And that is down here somewhere, so unfortunately we need to go bilge diving. Yep, it's down there. Okay, so there's a crack in this web frame. Boat's very deep, don't know why it's cracked. There's a big fin underneath the boat. Maybe it's like had a bit of a hit at some point and it's twisted and broke that. So we were gonna sister it with a straight piece of wood, but then we wouldn't have much bearing on here to get a fixing in it. So I think what we need to do is make a steel plate. So I've got some nice steel, and then we can do a U over there. They can come a bit higher, and then we can be fixed there and there. So we've got 4 fixings in each, then that'll support that. And the main reason for doing that and not cutting this out is because we want to replace these bolts. If we were to like put a piece on top, which would be probably the best solution, but then we wouldn't be able to get to the bolt, would we? So I think we'll make a steel plate. So should we make a template and we can take it to the workshop?
Because all of the keel bolts will be replaced, but that is a job for when we're on the hard. So it'd be so much easier just to get a piece of wood on the top and sister it, but we need access to change the bolts.
Well, that seems to fit quite good. I don't think we need to go all the way to the sides. That would make it awkward getting it in and out. We'll leave it high above this to give ourselves a bit more material along here. So we've got a couple of bolts in it, and that'll do. Right, next on our list of doom is lag bolts in the knees. I think we nicked these a while back, giving you like nick off Peter to pay Paul and stuff like that, but
Okay, so you've got a few more to do there. This side too.
yeah, we haven't stolen quite as many off this side, I don't think, but... So we spent a little bit of a debate. This side has got big washers on it, that side has got little washers on it. Obviously don't need big washers, but we're gonna make them match, but not match.
I also know there is loads of knees in the engine room that need securing, so let's go.
Right, so when we put these knees on in the engine room, we only use like M6 little pesky bolts, but we've got some nice decent fixings for it now, so unfortunately we've got to do, I think, about 20 knees. See, little piddly things. So we was actually sent out 2 new drills from Richard, so thank you very much. Right, these knees are pretty crusty. We brought them all home so we can do them in between jobs at home. But we live in an age, don't we? I'm used to an age of like points and condensers on engines and stuff like that. Very basic electronics, but this day and age, there's some amazing tools.
So we've got a new toy, and this is an Xlaserlab X1 Pro. Now this does cleaning, cutting and welding. Like, we've never ever tried laser welding before, but we thought this would be really good when we come to welding up all the nice stainless stuff all on the deck of Surrender, and really good for cleaning these. Okay, so let's set it to clean.
Safety and the coolness. Why is everything so green?
Right, so let's try and clean up this rusty knee. Look at that.
That is ace. Imagine the grinding disc you're going to save.
But what this is going to be really good on is like when you've got round parts that you can't like get a grinding disc on and stuff, and like engine parts and stuff like that to clean it all up.
All the engine parts.
All the engine parts. So I think this laser is going to come in very, very handy. That is cool, isn't it?
Should get the hang of it in a minute, yeah. Right, I want to have a go with this. Frickin' laser beams.
Frickin' laser beams!
Wow! And the rust is gone. That's ace. Kind of missed a bit there, didn't I? But how? How does he do that? It's supposed to shine lasers into people's eyes. Yeah, the red laser is just to show you where it's pointing before it actually goes into hot mode.
But how dangerous is this laser if it hits a wooden bench or a wooden boat?
Well, I was just going to see if it'll strip varnish off this old, very valuable piece of wood. Should we try it?
Okay. That's not for you to drink. That's
I was going to say I'm not actually that thirsty. It takes the varnish off. Right, we'll try and do it a bit neater this time, ready? Look at that. I mean, you probably can't, you guys can't feel it, but
That's what you call laser engraving.
But what I'm going to say is, we won't be stripping anything off the cylinder with this, because I bet if we hold it, no, that's just put a hole. I think I can go right through it. Should I go right through it?
What's this for?
We don't even need drill bits now.
I'll fix that wood, about 15 mil.
Yeah, plus.
So, they are quite dangerous. You've got to be really careful with lasers. It's probably not a toy that we will actually take over to Surinder because we could easily put a hole through it. But in the workshop, it's going to be fab. Hey, plastic withstands quite well. Went through dead easy when there was no water.
Go and try it through the water. So if it's got water behind it, it's alright.
Yeah. Oh, there you go, when Surinder's floating.
Oh, oh, it's leaking. She's leaking.
Look at that. It's like new again.
So considering it started out like this, and it's come to that, it basically just removes everything.
There you go.
That is amazing.
So I think we've got about 8 more to do.
Yay! So we said our delivery of plywood. This should do all the upper roof, the rear deck, and the side pieces on the boat. Unfortunately, we've had it delivered half a mile away from the workshop because there's loads of people doing work on the power lines. So it's here, but when all them have gone, we need to get this up to the workshop.
So now on the journey to get the plywood back to the workshop, we've got to go down there and all the way up this road. But the road we've got to go down is very bumpy, so will the forklift manage it?
think it's actually helping because we've got a lot of weight on the wheels. Normally you lose a lot of traction going through there, but we've got like 1.5 ton, turns out.
So that is 44 sheets of plywood, 1.4 tons. And it got delivered on Simon's birthday, so what more could he ask for? So that is enough now to do the rear deck, the rear roof, of the transom. Because
the sides.
The sides, enough to do the sides as well. But we're still going to order extra special plywood for the transom. So enough to get on with for now. So let's move on to the next job.
Right, so before we find out the other functions on the laser machine, we need to make our plates, don't we? The one with the little U in it. So let's get stuck into them, because I want to do them first, because I want to get them in paint. I did try and cut it on the bandsaw, but straight down, and then the bandsaw started to veer off. It doesn't like going straight down, so I think I have to cut these with a grinder. Right, so we need to repeat that now 7 more times. Wanted bad with the big grinder, so let's cut them out. Right, so there's 8 of those. After handling them, I've realised how heavy they are, and I've got to carry these over the mud tomorrow, maybe, after the paint's dried. Right, what we need to do now is drill some holes in them.
So these are going to be sandwiched together on the split. So we need to do the bolt holes now. So we're going to put our template back up. So our bolt holes are in the same position. And then we'll get our Sharpie.
Do you reckon that's going all the way through it, do you?
I hope so.
I suppose we'll find out when we take it off.
Is it just 2 holes? Or
4.
4, yeah. I mean 2 either side.
Good at counting as well.
Ah, there you go.
Yeah, they're proper vivid, them, aren't they?
And then to help you out when you're drilling, I'll put my punch in the middle. Give it a little knock. You know, you've just tipped all that on the floor.
Yeah.
There's like a bucket right there.
Is there? That bucket's not actually for that. That's my fire starting solution. Oh, that's fair. Right, we've drilled them now, and now we need to grind them up. So all nice, and then we can see about painting them. Right, so now they're all ground up, nice and smooth. We need to hang them up so we can put some paint on them. Bit low, isn't it? Right, so it's time to prime them. I've only got some leftover primer. It's good stuff, but they're two different colours, so let's see how far we go, and then if it doesn't go far enough, then I'll go and buy some more. I ended up having to go and get some more paint because I kind of run out. So we'll give that half an hour, then I'll give it a second coat. Second coat time. We're still the same colour now.
Well, these are all dry now. Oh no.
You think it's awkward getting them off? It was a pain in the ass getting them on.
And then we'll put them all in this nice padded box. Ready to take back to Surinder.
So now we've finished our painting, got all that done out of the way. We can now try and figure out what other uses this machine's got.
So we can also do welding. Now, we've not tried this, but we've got steel, welding wire in it, and we're on a stainless steel plate, so I don't know.
Wow. Holy cow. The first go, that's pretty good, isn't it?
It's quite fun actually as well. Obviously, we haven't even got like settings dialed in and stuff. We just switched it on and went go. So I think obviously fine tuning the settings and actually using the right materials and stuff, I think this could be fab.
It's supposed to say eyes.
Eyes!
Yeah.
Oh, I'm going to do something. Ah. Oh, I'm trying to run before I can walk. Oh, I'm a bit off there. Can you guess what it's meant to be?
Is it a broken heart?
It is now. Maybe I should just stick to lines for a minute.
Didn't say the word.
I want to stick something together now. We are.
Why don't you weld that piece? This actually come with it, and this is showing you what it can do, I think. That's the socket.
Yeah, there's room for improvement on ours.
Yeah, but we're considering straight out of the box. So, it's that good at welding, somebody who watches Love Island can weld.
Cheeky. So instead of just doing lines, should we actually try and like weld something to something? Can we weld steel to stainless?
Of course you can.
Using stainless wire? I don't know. The settings may not be right because we're on steel. And we just tack it. I don't think we've got our settings right, dear. Hold on. Do we need to... We've got it set for steel, but...
It doesn't make much difference. But yeah, that's definitely not right. Right, do you want a job as a laser welder?
I think I've definitely got some practice to do on it. But do you know what else this machine can do? It can cut.
So to go from welding to cutting, quite simple. Press that, press confirm. It's saying that you have to have it on an angle, not straight down. And then we're basically ready to go. So, I think you just press the trigger, don't you?
Genuinely the first time ever using it.
We're going to do a straight line.
Well, cut me something out.
Well, just try and do a straight line, hang on. Holy cow. Is that working?
Hold on, did we set like what? I don't know. Does that don't touch the end?
Oh, no way. I just burnt my finger. Right, we need to think about this. Let's not come back in a second. Right, I figured out very quick trip to the manual. Should always read the manual first, shouldn't you? Well, you have to focus the beam of light, and I think we had it focused on the back of the tip. And we did try it again, and we started the tip just started to glow orange. So right, let's give this a pop. Now we've got a focus in it. So do you want a perfectly straight line, dear? Look at that! That's like, holy shit! That is freaking laser beams, isn't it? Wow!
Look at it.
Holy cow!
I think you've even marked the one underneath. I don't want to touch its top, but look.
Can't cut it, has it? No, just mark. Holy cow! This is good. Right, so I'll just do a line. Okay, ready, a line. Ooh, scared me then.
I jumped in.
It's like you can't even measure the thickness of the line. Well, you probably could, but like, you know, use a plasma, and the plasma's like, it's got loads of like, no, what's it called, gross or something like that on the back of it. This is so, this is precise. This.
I want to go.
That's just mental, isn't it? Right, Gemma's on the helm. Yeah.
Wow.
Do you feel powerful?
Yeah.
You do, don't you?
Yeah. That's awesome. Did you like my smiley face?
Well, at least somebody's happy.
That's a new key ring for you.
It's even got like the imprint in the background.
That's awesome, isn't it? But like, it cuts like really clean as well. Smiley face. That's my first ever laser cut smiley face.
Happy face.
So we've got a sheet here that we have already cut with a plasma.
So
Now,
it's like nasty on the back. 3mm alley.
Right, so this machine cuts up to 3mm.
Yeah.
So let's see if it'll actually go through.
And I've also got an assortment of other stuff here as well. So I've got some like painted scabby tube, some rusty off-cut box section, I think that's about 3mm, some thicker alley, some copper, and some like, I don't know, 3mm angle. Which one are you going to start with?
I'm going to start with the copper.
Do you reckon it'll go for the copper?
Yeah, I don't know. Do I need to clean it first?
No, just run it.
Just run it?
Yeah. I don't like it, does it? Oh, is it cutting?
I don't know.
No, it doesn't like copper. What's the angle?
3 mil.
Don't forget the angle to it.
3 mil box section. Did I miss a bit?
I think you missed a bit. Maybe start a fresh one.
No. You're hot.
No.
There you go. Went through that.
Not bad. Right, so copper, no. Steel, yes. The copper's quite reflective. I don't know. I'm sure someone in the comments will tell us why they didn't like the copper.
Right, do you want to go?
Yeah, I'll have a quick go, then we'll try some alley. Right, so I'm just going to have a go on this steel again, because I'm quite intrigued with being able to cut the steel. Not bad, that, is it?
Oh.
Right, should we try the alley? Is it cut alley?
Right, can you not cut through your feet?
Yeah. No, it doesn't like alley.
You also burned something on the floor.
I don't know whether that's a good promotion or not. Oh, sorry. Come on, let's try and burn stuff on the floor. Come on. You ready?
No!
Oh, no way.
Stop it!
This machine, right, it is an amazing machine, but you need to sort of really respect it. You need something behind you. Yeah. Right, what else should we cut? Right, so now we're going to try some painted, really nasty, horrible steel. No messing. See, plasmas and stuff like that don't like contaminated because they rely on like the electricity to conduct, where this doesn't. It doesn't matter what it is, does it? Alright, now let's try this sort of this about 4 mil, I'm gonna say. Rusty steel. Effortless.
Wow.
I'm not touching it because it'd be hot. Well, wood. Will it cut wood?
Simon. He's always got to take it a step too far, hasn't he?
This might be sort of pushing the boundaries a bit, about 15 mil. But no. It did go most of the way through it, but I mean, obviously I don't want to set the wood on fire. Right, so a bit of a Roco. This is obviously one of our old scarves. So we'll try on this skinny bit.
No way.
It's laser cut, isn't it? Do you like all these laser cut models and stuff?
Wow.
That's how it's cut, isn't it? Do you remember like them old machines you used to buy?
Yeah, look at that.
The actual machines used to be like horrific money, and now they're not.
Yeah, that cut really well through wood. Bonus. Definitely not taking it on the boat though.
Is it sold to cut wood?
I don't know.
Right, let's try a bit thicker. Yep. Yep.
You've just cut through a leaf as well. That was on your plate.
So yeah, when we were saying about the danger before, we've just put a piece of metal on the floor. Because obviously, I think the further away you are, the less power it's got. So yeah. Have something behind you. But there you go. Hole.
Wow.
We don't even need a drill.
No drill bits no more. You can just laser cut.
No drill bits.
Okay, that's quite good, isn't it? Cool. Right. I think before you cut anything else,
Yeah.
put it away.
It just frees up possibilities now of work we can do in the future, doesn't it?
So if you're interested in the Xlaserlab, there is a link in the description, and if you use the code SHIPHAPPENS, you will get 5% off.
Time for a sawing break now. I like sawing. I found out to do multi-packs. But this is the last one. Do you want half?
Oh, do you want it toasted? What you saving, Trey? You're sawing.
Do you want a silver platter? Right, glasses. There you go.
Toasted. Oh no, it's a bit overdone.
Yeah,
Steaming.
you better overdone that. A bit burnt.
I don't fancy it.
Yeah, come on, get it down here. Eat it, eat it.
But it smells burnt.
It is burnt.
It's warm though.
You don't like that?
No, I don't like that burnt taste. I'll just cut the burn off.
Okay, so we figured out a limitation there. This is not very good for the food industry. Give like thinly sliced ham. Ham.
I haven't got any.
We haven't got any. But no, I don't think it's very good for like cutting food. Sticks and knives. I'm going slightly off piece there, but it's only good for 3mm they recommend. But we see Sean has got one of these machines as well. For Sean at Saving Blue Steel, and he was managing to cut 4mm with it. So we need to try and one-up him, don't we? And try and cut 6mm. So these are actually offcuts of our 6mm plate that we were cutting out for the sister things. Don't think, oh yeah. Okay, so it didn't actually just fall away, but.
Oh, that was easy.
But yeah, it did cut through, and it's not the neatest, but you could easily tidy that with the grinder.
Impressive, that.
So there you go, Sean. We can cut 6mm with ours.
On that note, before we start a channel rivalry, we are going to head back to the boat and fit these things. So come back next week to see what else we get to.
We might be doing something a bit off as well, aren't we, next week? Should we say it, but then we might not do it.
Fuel tanks.
Fuel tanks.
See you next week.
Goodbye.
Bye.
Oh, God, it's heavy. Wow. You got that?
Yep. Why does the fuel look blue? Like...
It's like blue diesel.
Does running a dual wire feed on a small 700 watt laser make sense over the single wire feed? Let's try it out. This is a brand new dual wire feeder for the Xlaserlab's X1 Pro laser welder. Now, I've been using this welder for the last several months, about 4 or 5 months with the standard single wire feed, and I think it works really well with a single wire feeder. I have several videos that are up using this welder on the channel. I'll link those in the description below if you want to learn a little bit more about it, see some material tests, find out if these welds are real. Now, I'm truly curious how much benefit we'll be able to see with a dual wire feeder on a 700 watt unit, because this is on the low end of the wattage, though I've actually found it to be a lot more capable than I expected. If you've seen my other videos, you'll see the results of some of those tests. Let's compare this thing to the single wire feeder on a few different joint types. So here's my X1 Pro sitting on the cart that I built for it. Now, I built this in a video actually using the X1 Pro. So if you're looking to build a cart for yours, be sure to check out that video in the description. And up on top of the cart, I have the original single wire feeder loaded up with some 0.045 or 1.2 millimeter steel wire, just ER70S6 MIG wire, which I've found to work really well. And this wire feeder is really a pretty nice one. It has dual drive rolls, and it's an actual Swiss feed mechanism. So I've been pretty happy with the wire feeding itself out of this machine. I'm going to be running some 1/8 inch thick or 3 millimeter thick steel today, and I'm going to run it in 3 different joint configurations, all of which have a fillet weld. So the first configuration will be a T-joint like this. The next configuration will be a lap joint like this. And the last configuration, which I expect to see the biggest benefit actually, based on my conversations with them and my experience, is gonna be the outside corner. See, outside corners like this typically had underfill, and I'd have to make a couple of passes. So far using the single wire feed. So I'm hoping to see a lot of benefit here out of the dual wire feeder. It's like magic. So cool. I'm excited to compare this with the double wire feeder. Once again, beautiful little joint there. I wouldn't mind a bit more fill and to have it spread out a little bit more. And lap joints are one that they said they've seen a lot of benefit from the dual wire feed. So I'm excited to see how that affects it too. Last up is the outside corner. Again, beautiful little bead, but I would like a little bit more fill on there. I would probably run a few more passes. Let's take a look at the unit itself and the included accessories. The full metal case, pretty sturdy build, and you put one roll in one side and another roll can go in the other. Now it has wheels on the bottom, but it's kind of a unique setup. So with the handle extended, you just roll it around like a suitcase. And while I appreciate the creativity, I think if you had 2 full-size rolls in there, so you're 80 pounds with the wire and the unit itself, that's gonna be pretty heavy for this mechanism, but could be pretty useful. I'll probably just set it on a cart. The front panel is similar to the single wire feeder. You just have a wire feed and retract button, which is really nice. Not as nice as if those were on the gun, but it is nice to have them directly on the unit. Let's go ahead and take a look under the hood. So it's still dual drive rolls on both sides, and rather than a Swiss feed mechanism like the other one, this is an e-power. So this is a Chinese made wire feeder that looks very similar to the Swiss feeds, but has a few differences. Now this actually uses a spur gear to engage the idler with the drive. So your true 4-wheel drive all the way through here. So a really, really nice setup there. Now for the dual drives, there's just a single motor. It's a healthy size motor that's attached here. E-power once again, and that connects into a metallic gearbox, and you have a direct actual geared connection between the 2 sides. So they're going to be synced up for sure because of that solid build. So pretty solid build here overall on the wire feeder. Definitely nothing to be disappointed about. It is sized to fit 2 full 12-inch rolls with the, the 4-inch wide rolls. That is a ton of wire for laser welding. They did not include adapters, and I was surprised to see this, but there's no adapter to bring this down for an 8-inch roll because, if you're buying aluminum rolls, stainless steel rolls, you might not want to spend the full amount on a 12-inch roll for laser welding because you just don't go through as much wire as you do with MIG. So I'm actually 3D printing a couple of those adapters as we speak. Of course, includes the electrical cable as well as the dual cable here. So it just has 2 connections to go into those wire feed ports, and it will feed out into one connection here that connects up to your gun. Now let's see what came in the goodie box. You know, if you do any mechanical assembly on a fixture table like this, this is a must-have. Go pick one up at Harbor Freight. One of my best purchases from there. Anyway, let's pull this out. We have a variety of different welding nozzles here, and then also drive rolls. And what I'm impressed with here is it includes, I mean, in the machine there's a set of drive rolls, and then there's 1, 2, 3 additional sets with V-shaped rollers for solid wire steel and U-shaped rollers for aluminum. So they have specialty rollers, and that's a big upgrade and going to be really helpful. So I'm impressed to see that. Now here is the whole song and dance you've got to install onto the gun. So I'm going to figure out how to do that now. So I'm about to connect up the feed cables, and one thing I will note is these things are long. So it's going to take a little while for wire to feed all the way up through them. Now each side just slides in like this, and rather than using the threads on that end, you just secure it with this screw. Like I said before, they didn't include an adapter for an 8-inch roll, so I found this one online and 3D printed it, and that's just amazing to me that you can do that, except that it doesn't fit. And the problem is it turns out they just let anybody upload stuff to the internet. So I drew up my own right here, and I'll throw that on there and load in the wire. Now the spool brake on this thing's pretty good. It's one of the better ones I've seen, not the very best I've seen, but better than most. Now I'm going to back these off a little bit. Most people run these idler tensions too tight on MIG welders, and I assume the same on these wire feeders. You don't need it that tight. You don't want to put all that wear on the mechanisms. Now the fastest I can set my wire speed here is 50 millimeters per second, which is pretty slow. It really needs like a jog feature, unless I just don't know about it, but I'm not aware of one. So I guess I'll just press the wire feed button and hold it for as long as it takes. We have wire. I've got to assemble this whole space gun. You've got this double cable. Ferrule fits into here, and then this slides into there, and then a tip here goes into the end. I think it's going to be better to put this whole assembly together and then slide it into the gun. Okay, here's the setup I ended up with. I put this linkage back in to get a better angle up here, and I'm keeping this contact tip right here up close to the nozzle to be able to keep the wires side by side so the cast of the wire doesn't have an effect. Let's go ahead and run this on a T-joint. As I got to looking at this, look, it's like there's a total lack of fusion down here in the toe of the weld. And I think that the wire is getting in the way. So I'm turning up my scan width here, and I'm going to try this again. But I will say that result looks pretty nice. Looks to be a little bit bigger than the other. We'll measure it and compare these dual wire feed with the single wire feed here in a minute. Let's go ahead and move on to a lap joint. Pretty slick little weld. Easy money right there. Definitely some more fill. Let's go ahead and compare these. All right, let's look at the T-joints here. This is single wire feed. This over here is with dual. The fillet weld size is the most obvious thing right here. I did my best to measure it with calipers. This is right around 80 thousandths of an inch, where this is about 100 thousandths of an inch. So 25% bigger on the fillet weld size. It's a little bit more consistent, as you might expect. And notice it's a little bit cleaner, not quite as much oxidation. That could be a few things. One, the nozzle for the dual wire feeder is a little bit bigger, and I did turn up the gas flow a little bit because it was, you know, a larger area. So that could have just been better shielding, or perhaps the additional wire is kind of a heat sink. So that could be drawing some more heat out of it here on the surface. So either way, they're both totally acceptable results visually, but I think that you know, the larger fillet weld size could be nice. Now from a weld testing perspective, I'm not going to take cross sections and etch them today. I just don't really have bandwidth to do that. But I will run a fillet weld break test where I'm bending them open from the root. So all of these welds are only run on one side, and it's really a worst case loading condition. So if they do break open, I can see if I got penetration all the way in. If they bend over rather than breaking, you can assume it's going to be strong enough for most situations, because this is really a worst case loading situation. That root is not opening up very much. Let's see if we can't clamp this tight and get a little insight here. Held up really well with the single wire. I've done a lot of testing with the single wire, including cross sections, lots of fillet weld breaks, so check those out in other videos, but no surprises here. Now for the big one on the twin wire. Once again, not welded on the back side. Yeah, that root is holding up really well. Yeah, that's not budging at all. Fact of the matter is, either one of these is going to work just fine. I don't know that you have a huge advantage from running the twin wire on this, but it definitely doesn't hurt, and I think you would have a little bit more durability. Now if we look at the fillet welds on lap joints, this right here with the single wire, this on the right side with the dual, the single wire is a much smaller fillet weld size. Once again, significantly more material deposited here with the dual wire feeder, which you'd expect. Both look perfectly acceptable. But if you did want to have a little bit more fill for, you know, aesthetic reasons, or even from a strength perspective here where you're dealing with a lap joint, this could be beneficial in some cases. Now let's bend open the single wire lap joint. It's not welded on the back side at all. Now this one is opening up at the joint. Let's just work it back and forth. Now this one opened up pretty easily. I didn't have nearly as much penetration into the joint as I've seen on other lap joints like this, but you know, real world results, I'm going to show you what I actually ended up with. And it looks to me like that was a result of this shear cut edge. It rolls up, so I don't really have enough material to consume that when I'm depositing with the single wire. So still probably strong enough for a lot of things, definitely decorative things, maybe even some structural things, but certainly would like to see more strength than that. Now let's try the dual wire lap joint. Yeah, there's a big difference there. And they said that when I was asking what a good application for this dual wire feeder is, lap joints and outside corners, so you know, this is not necessarily a surprise. So there's just a whole lot more material there to cover it. This first one, in all reality, was a fairly poor performer compared to others that I've had. Now that I switched over to the dual wire feed, I'm not going to rerun it. You can watch those other videos to see, you know, you can get a pretty sound lap joint, but this definitely exceeds what I've seen. For a lap joint, just laser welded on one side with a 700 watt machine, mind you. You got to admit, that's pretty stout. Now here on the outside corner joints, there's a huge difference in the amount of fill. Here with the single wire, there's definitely not enough fill to just grind that down to a corner and have enough reinforcement there, right? You'd have a weak corner. So if you were building, let's say, like a big diesel tank and you wanted to run all the outside corners using laser, you'd need to run multiple passes with this, where here with the twin wire, I think you could just run the single pass here because it's filled in enough, just a quick touch with the grinder to round things over, and you'd be in really good shape. So I think for that application, the twin wire definitely has a lot of advantages. Here with the outside corner, we've got a single wire. Backside, you can see we got good penetration all the way along. Pretty strong. I mean, I'm pulling pretty hard on this, but it is yielding in the joint just because that material is fairly thin. So see it closed up like a book right there. but it's holding tight on the root. So if I work at this, this one's gonna pop open. If you take a look at that fracture surface, it's just not that big. I mean, you got here with the dual wire feeder, you can see it's pretty full. I would touch this with a grinder just to take off those edges, but you're gonna have a whole lot more reinforcement through there, and you still see that good penetration right through to the bottom. See how it's not bending open because you have so much more weld deposit there. So definitely some benefits there on the outside corners too. Obviously you could run like 2 or 3 passes and end up with the same result if you didn't have a dual wire feed, but single pass, this is what I'm seeing. All right, to wrap it all up, I'm gonna answer the 3 questions that I had about this product. 1, is it well built? Is it a good quality wire feeder? 2, does dual wire feeding provide any benefit? And number 3, is it something that I would use you know, in a practical situation? And to answer the first question, is this a well-built machine? I think overall it is a really well-constructed wire feeder, especially given the price point. Right, when you get industrial wire feeding equipment on you know, MIG welders or things like that, that can be in the thousands of dollars for a high quality feeder. This right here is well under $1,000 with dual feeders, comes with a dozen drive rolls, all the hardware you need, 2 feed tubes, it's got the nozzles and all of that. So I think when you factor that in, it's really well made. Now let's talk about whether there's any benefit to running the dual wires, because I was pretty skeptical as to whether you'd see any benefit, especially on a 700 watt unit. Now on the fillet weld and a T-joint on this 1/8 inch, remember we're talking 1/8 inch thick material, which is kind of getting to the top end of what this 700 watt unit is really set up to do, at least on the regular. I don't think there's a whole lot of benefit for the fillet weld on a T-joint. Seemed to be pretty apples to apples. So you did get a little bit more size, maybe a little bit more durability in a cyclically loaded environment where you might have fatigue. But for most stuff, single wire is fine. Now, when you got to the lap joints and outside corners, just like they told me, that additional fill seemed to make quite a bit of difference and really had a positive impact. So I think there is a benefit there. Now the third question, am I gonna use this on the regular? I think most of the time I'll still probably use single wire feed. It's completely adequate for most things that I do. When I get up into thick material, I'm still running an arc process most of the time. And so the single wire has been a really nice fit. That being said, if I was running a whole bunch of outside corners, you know, on larger tank or something like that, I probably would set it up and it'd be worth the benefit. And you know, if you aren't sure or you think you might use it sometimes, you can use it as a single feeder. You can just load in one roll. The other one will just spin free. And then if you got yourself the feed tube and mechanism for a single feeder to go along with it. If you want to learn more about this laser welder, see a whole ton of testing across a wide variety of materials and thicknesses, as well as practical fabrication projects, be sure to check out the videos linked in the description below where I go through all that. And if you do want to pick up any of this, there is an affiliate link in the description along with any current discount codes that help to support the channel. So I really appreciate that. If you're buying it anyway, it's no extra cost to you, but if you're not, if that's not your thing, no worries at all. Hey, thanks a ton for tuning in. We'll see you next time.
All right, guys, we got our favorite collaboration happening again. You guys asked for it. We invited Vince back into the shop to teach us all things welding because I got a little bit of experience, but he's got 1,000 times more. And we need that because we are going over Xlaserlab's X1 Pro that they sent us to try out. Now, Vince, you got a pile of experience with welding, right?
Yes.
A pile of experience with laser welders?
0.
We're gonna see what it takes to get this going. We got good news because not only are we making sure that it's a good fit for you guys, we're also giving one away at the end of the video because we've got a bunch of new merch. And no, he doesn't have a sniper on him. Vince is all clean, there's no warrants for his arrest, there's nobody after him. So stick around, see how you guys can get your hands on a free one. But we have a freaking laser in the shop and we want to check this out. Let's get into it. How is your pacemaker?
I think it's up to date. I think we just need a shark and we can take over the world. That's a start.
first time we've been able to get our hands on a laser welder, right?
Yes.
So I've been welding on average an hour a week for the last 20 years. You?
Average 50 hours a week for 20 plus years.
Okay, so Vince has a lot more welding time than I do, helmet time we call it. And I thought I was a good welder until I saw your welds.
Yeah.
Even still, these things used to be $50,000 5-10 years ago. They're $5,000 now. So now a shop like mine has a really good use for this, because not only does it weld, it also cleans, it removes rust. It's a cutter. We live in the Rust Belt. Rust sucks. I think I have more hours on a grinder than you do.
Maybe. Took me a long time to become a good welder. You're always a better grinder first.
Okay. So the first things we want to get out of the way is the PPE. It doesn't act like a normal welder, and it's dangerous in a much different way. Basically, there's 3 different kinds of welding. There's stick, there's MIG, and there's TIG. MIG is super easy. Wire gets fed, gets electrified. It melts the steel, melts the wire, and joins the metals together. Stick is a little bit more difficult. Your angles and your speed, and you have to do a lot more control. Overhead is a lot more difficult. That would be the next more difficult one. Same idea, you electrify a rod. It gets close to the steel, creates an arc, melts that rod, glues the 2 metals together. TIGging is a whole different art, because now you're adding 3 things: controlling the arc with the foot pedal, controlling the arc with a wand, and you're feeding in your material with your other hand. So you only have one leg not doing anything unless you're on a rotator and you're spinning that with your left foot and chewing gum and singing tunes in your head at the same time. That's what Vince does. So he's got that art down. He's like a drummer. He doesn't even know it. He can pick up a drum kit and start banging away. When you see anybody welding, you automatically walk away. We've been experimenting with this thing. It's so quiet, you don't even know that it's welding. And what this is basically taking a giant amount of light and concentrating that, almost like a magnifying glass, into a tiny spot at the tip of the gun through a lens, thereby melting the wire that gets fed in there. And that's what joins the metals together. In doing so, it's able to do very precise, nice looking welds, compared to the other 3 I just mentioned. When you're welding, the light actually reflects off of the shiny steel, especially if it's stainless or aluminum, and can bounce back up and hurt somebody inadvertently, or burn a hole in cardboard, anything flammable that's close by. You need to be aware of everything around you, at the same time protecting yourself and covering up all your skin. Even though when we clean the steel, you don't see all this stuff floating around in the air, it's still out there. Respirator is still needed when you're cleaning off stuff. So just keep that all in mind as we move forward. Seen a lot of videos out there with people not wearing sleeves and that. It is dangerous. It is still a giant UV light that will do some damage.
I would suggest that you double up on your eyewear, extra protection. Okay, the unit comes with a lot of different heads: regular joint tip, outside corner tips. These are for your bigger swing, for a bigger puddle. Not quite a puddle, it's more of like a laser weld. It's a little different to me.
It lets the light dance.
It lets it dance, yeah. Lets that laser bounce around a little bit in a bigger field. 2 of everything in 1 box, 2 boxes, so 4 of each. Quite a bit actually. Most units don't give you that much. It says you hook the ground up to the gun itself, which is new to me. Rust appears to be gone. Probably up a little high, a little bit of etching.
I think it's a pretty narrow tip. Try this guy. Yeah, try that.
Try going side to side so we don't etch. Way better. On this corner here, you'll never get in there with a grinding disc, especially when this is detached to the car. That's impressive.
Yeah. Wow.
Yeah.
There's a little bit of paint gone, so see if you can make an arc with that and then take the paint off on the side. See what kind of smoke comes off of that and like toxins.
Definitely etch the paint off. Not much heat implied in there either.
So that did leave a mark. Yeah, and it all comes down to just speed and finding the right settings. And that's where the helmet time comes in, where you get used to the machine and we don't have anybody to set up all of the settings for us. We're like, oh no, you need this many hertz and that many duty cycle and this much percentage to get it perfect on this steel, right? For whatever you're doing, but it knocks the paint right off. So that's really cool. Being able to figure it out in an afternoon or a couple hours is pretty user-friendly, actually.
I'm gonna go on cleaning mode and try to get some scaling off of this greasy piece of metal. Looks a little shiny, not as shiny as last time. I cleaned it, digged in a little bit, so it's probably a little bit high. So it just eats that right up. Definitely new to me on how light can do that. Oh, I just did some cleaning action on there with the laser. Looks pretty clean. Looks like it's got a little bit of particulates on there and stuff, but I guess we'll see what it does this time. Yeah, we're gonna lay a little bead here. Doesn't seem to be that clean, hitting rust. So maybe it's not deep enough on this particular piece. Yeah, it's deep. This looks like a factory test plate. So shows like the heat deflection in there. There's a bunch of different coloring going. We got blue to red to a little bit more colder, but right here is like a really nice color, really nice gold. So this one's a little hot. That's probably their third pass. First, second, and third, I would say. That gold one's optimal. But I'm guessing that myself just with TIG welding. That's what we're shooting for on stainless steel, is the gold. The other side, it looks like they got some stitching. So they probably got a pulse setting on there for arc distance, and it'll shut off, and then it'll go, and then it'll shut off, and then it'll go. Do some 16 gauge, see if this heat is okay. A little bit cold.
Did it work?
Yeah.
It did?
Yeah, put a little bit of a bead on there. Didn't seem to open up. I think it's a little bit cold still, but I think that might be the hertz.
It didn't make any noise.
It didn't sound the same as last time.
No.
So I think it might be to do with the hertz.
Okay.
It's very tiny. The welds are very small. I would have a cheater lens in these glasses. Seems like consistent travel speed is quite key. That's a nice looking little weld. Not too much heat in it. It's not, if I TIG welded that or anything, I wouldn't be able to touch this. So it'll more than likely break, but not that bad. That's good, man. Not a terrible amount of penetration, but that was pretty tough for something so thin. And we're at 60% power. We were at 50%. So I'm assuming that's just more focus on the laser itself. I don't think it has to do with amperages or anything. It looks good. I think my travel speed might be a little slow because of the heat transfer. That's how wide that is. A little off kilter here on my angle. Right from there to there is quite nice, and that's pretty fast for sure. Not perfect, but that's my second time, and you know, I think most people with most equipment would have blown that right apart. I think my travel speed might heat quite a bit, in a sense, because I'm getting a little bit of warpage on that, but it is pretty thin, and that's a pretty long bead on something so small. We've put a bead on here on a single side and did a bend test over, and it held pretty good for being, it's like a 2.5 mil, 3 mil weld. I would say that's pretty strong for that size. Double-sided, you're not gonna break that apart.
I see which one you did first as you're getting better. But like any weld doesn't matter. If you only weld the one side and fold it over, you're gonna crack it, right?
Yeah, 95% of the time.
Yeah. That's a beautiful looking weld. But the nice thing is absolutely no splatter. You do your settings and away you go, right?
Yeah.
So this thing also cuts, but it acts different than a plasma cutter. If you know what a plasma cutter is, you've got a flame that's about this long. Better ones have maybe an inch, inch and a quarter, lets you cut through inch and a quarter. This, however, light just travels past it. So always gotta be conscious of what's on the other side. You're cutting on a vise, you're gonna cut your steel toe right open, or at least warm up your boot to where you get blisters on your toes. Like it'll cut it, but that's definitely the max. That's a quarter.
There's a pretty good community on Facebook and stuff that has some information going on about the machine, and what they're using and what they're finding the best results with as well. So if you're gonna try cutting, they suggest use compressed air, so we'll give that a shot. Cutting configuration, not straight up and down. Angle cutting is permissible. Confirm, 100% dirty cycle, 1000 hertz, 100% power. So just trying to figure out the angle, push or pull. I'm assuming that these should be dragging, but as I can tell, it's probably very important to have a water table under you because that laser is going clean through this onto the workbench. You gotta be very cautious of your feet. Very unsteady hand on that one, but a lot slower travel speed seems to cut. Floor on
It's catching the floor. Direct my floor.
Oh, he cuts that fine. Aluminum's a go. Body metal a go for cutting. Just got to practice on the angle. Give it kind of beat it lays down in there. Material's a little bit thick, but it seems to be biting in there decent. Pretty nice weld, minus the crappy tacks in the corner there. But That was relatively quick. I'd say stainless is a good go. Looks nice. Pretty happy with that.
Go right over top, you say?
Yeah, sure, why not?
All right.
Or well, lay one.
I'm just
sort of
gonna
flat and then-
I'm just gonna make sizzling noises with my mouth and then say look at my weld. I'm pretty happy with that. Like you see, I wave a little bit because I wasn't supporting my hand properly enough. But yeah, once you have the settings, then you kind of know, and it's nice to be able to program them into the wand and then just pick it up and go. Right? If it's something that you do the same thing over and over all day, every day.
Yeah.
Would you say you're as reliant on the argon gas when you're welding as you are with like TIGging?
Yes.
Yeah? Okay. So you still don't want fans and stuff in there because at work they don't even give you fans because they much rather sacrifice your health for a nice weld. It's not as intrusive as a normal welder. Wondering if Xlab can maybe just take one of these and put the film over top, a removable film, so you can put it on this because then at least you're not breathing that crap in, right?
Okay, we're gonna attempt to do some aluminum welding. I'm gonna do that without wire. Wire's usually a little janky and stuff. Most guys don't like to weld aluminum wire. It gets jammed up a lot. It's not my favorite process at all. Let's give this a shot, see if we can get just a lap joint.
Well, there we go.
Yeah, no filler, just laser.
Oh yeah?
So, it'll definitely melt the two together.
Yeah.
Pretty good fusion there. Looks like it's embedded good. Definitely not structural or anything, but
It sounded like it was going really good, but you're saying no fillers, it's not structural at all?
yeah, I think that would just be like just to seal something up.
Okay.
In general, no pressure.
Run a pass in the middle there. We can cut it and then see how much it takes. Yeah, see if there's any fusion in it. Let's take a look.
A little glitchy, but that was a little tricky to see. It's very small. Everything's very tiny. See if it's got any strength. $2 mil in, maybe. What do you think?
Yeah.
So and that's against itself. It's a strong way, but that's no filler. So I mean, that's
If your metal is too thick,
yeah.
you can't get the heat in there, right?
Yeah.
So then it doesn't pull it in. Whereas with the TIG, you can warm it up a bit, get a little bit of heat in there before you start putting.
You're getting a nice pool.
Right, right.
This doesn't seem to create too much pool, but as it gets hot at the end, it's starting to sink in there.
So if you preheated it somehow and then did it, you want to try it again and we'll just warm it up?
Yeah.
Okay, how can we warm it up? All right, we got this out of our easy bake oven that I stole from my daughters. It's not super hot, but which way are you going?
Flat.
Oh.
Yeah.
About 150. It's about really didn't get that much hotter. It's like 175 was the hottest. Oh no, about 200. See about 200 in the seam there. So yeah, let's see if this goes even deeper.
Definitely faster than TIG. With just that, no filler.
You want to cut it in half? Yeah, you can't see anything. Looks like one piece. Whacking it is more fun anyway. Is it stretching? It's not. So it's just starting to crack on the outside here.
Yeah.
Just a hair, and that's only. Here, let me cut the. I think you got almost twice the penetration as you did without having heated. Yeah. So that's really interesting. That's kind of, it's good and bad. It's a downside that like you can't heat it up with the torch, but if you heat it up another way, you get that really good looking weld off of the laser, right?
Yeah, I wouldn't be afraid to do a gas tank with that, but I don't know how you can get into corners well and things.
Right.
Being a gun.
So you wouldn't do boost pipes with it. 30 psi. These are the two factory ends, right? If you were to put the two factory ends together, I can't get a cut any nicer than that.
Yeah,
but if we wire wheel that, we can plug this and pressurize it and see when it blows up. It will be a giant explosion, but
I think having the way it's covered is probably good. If you do blow a hole, that laser's gonna bounce around in there and come right out the end. So you have to be very cautious of the laser at all times. Apparently, it can reflect very much so. Hey, that's pretty fast. There's got pretty good penetration internally, but I would have to get a mirror to take a peek down in there. Just like to say that the fit up would definitely have to be perfect because the laser will just go right through the gap. Might be able to handle the gap a little bit with wire, but gaps are usually not your friend. Swing. So it'll go from like a 2 mil swing to a 4 mil swing. So I think the laser itself is rotating internally, wider puddle. So if that was on a rotator and you were just sitting there like that, focused, and that was spinning.
And back purging too yet, right? That's really cool.
First attempt on that gauge or aluminum with just a laser beam. So.
Right, so just imagine 50 hours of helmet time by the end of the week, what your welds would look like, right?
Yeah. Let's see if I can get these pop cans tacked together. Extremely hard. You have to be pretty darn good at TIG to even accomplish it once in your life. So everybody tries to get one and they use that as their resume. If this can do it, I'll probably weld anything.
Is it really a resume thing?
Some guys bring them in. I've seen it done. Cans are getting thinner nowadays. Paint's an issue with all welding. There we go, that should be a pretty nice little seam. Still paint in there.
There's still paint. But use the yeah, but use the laser. Use the laser to clean the paint off, and then shoot it.
See if we can get underneath that little lip in there.
Definitely no rust in there.
Or you were just cleaning it?
Yeah.
Oh, okay. I was gonna say that weld looks like shit, man.
Nope.
No?
And goes through. Got a little hot at 30%. Try down to 25% power. Just dirty from sugar and stuff in there, but I mean, here it's punching through at 30%.
Yeah.
So too much. Here, sugar, but it's welding. And then right about there. So you can see all black soot and stuff like that. It's just contamination like crazy.
You're putting that in your body.
Yeah. We remove all the rust off nails with that stuff and we put it in our gut.
Yeah.
So I would just assume that's potentially achievable if you really fine tune it. Yeah, from the factory before it's got the syrup in it.
Yeah. Okay, so for the underwater welding, We got this nice tote, and just a reminder for a life hack is to keep a 40-year-old refrigerator in the garage, so the one just as a backup for when the one you bought 2 years ago breaks. But make a really nice crisper, and this should work fairly well for working underwater. Is your insurance up to date?
Yes.
Yes, you got all your affairs in order just in case you get zapped and catch fire or bounces out or something. And okay.
220, that's not much.
How is your pacemaker?
I think it's up to date.
Okay, all right.
We're gonna try a weld underwater. This is definitely a first for me. So a little nerve-wracking, but we'll give her a shot. Definitely tricky to see with all the bubbling. Must be different settings. Very hard to see because you're working in bubbles, so I can't see anything. There's gotta be a trick to that.
No smoke?
No smoke. But then I think, you know, like the material's probably like ice cold. Yeah. So I'm, you know, like might have to really ramp up something on it. I was trying to weld underwater here with some wire, but doesn't seem to be working for me yet. Don't know exactly what settings we have to go with. Yeah, 48, now we're at 65. I guess that's a little bit of fiddle farting around. So we're gonna try it without wire and see if it'll get at least a bead going. Can't see anything out through the bubbles at all.
Saying don't submerge it under the...
Just the tip. I guess we won't get so many bubbles and we can see. I think it welded there.
You think so?
I think 2 pieces would. It's etching it, so. A little bit of etch. So no wire though, eh?
Do you want to try with wire now that we've sort of got it working?
Yeah.
Is it doing that?
Went up. No.
If you guys have one of these machines and you experience something different, make sure that you comment that, because maybe we do have settings wrong, or maybe we just had something incorrect, you know. Definitely join that Facebook group.
I had a lot of fun trying this machine out. It looks like it has a lot of different applications. I'm very impressed with the rust cleaning. Nobody likes to grind. The tubing aluminum, relatively thin. It welded that seam no problem and very quick. So I've enjoyed that. I'm assuming fit up is crucial, which usually always is. That being said, the seam was a factory edge and it welded up just fine. Cutting takes a little bit more of a learning curve. Underwater, haven't figured out yet, but it'd be interesting to see that done just because I've never done it. I'm not sure what application I would use that myself. It suggested that when you're welding underwater, you get less distortion and stuff and a stronger weld apparently. Yeah, so that seems really good. Once you have everything figured out and fine-tuned, I think you'd generally be pretty happy with that. Generally, you gotta be pretty careful with this because it's laser beam. It has potential of starting a fire very easily. Definitely blind you and or cut your toes off if you're cutting and you miss your table. So I would suggest always use a water table or something like that. The machine can be hooked up to a CNC. Use this as your cutting head. I think I would go with this if you're working on a really light gauge materials. It seems like it has less heat distortion, but I think in a sense it's a little bit limited on your material thickness and stuff. So a little bit more of a specific application than say a TIG. The digital screen is very nice and friendly for the user. Feeder is very nice, works well. I would say the quality's, you know, at par with anybody else out there on the higher end at that. So liner and the fittings are all very nice. Seems very durable. Different style than I've ever used in my life and stuff like that. I'd say the quality's excellent.
All right, so it's fine watching a couple guys having fun experimenting with something that they've never done before, but it's something completely different to do it in your own garage. And we've got exciting news for you guys.
Hey, welcome to the shop. Today I'm going to use a laser welder to build an actual fabrication project. I've been getting to know this process over the last month or two, and most of what I've done has been coupons on the bench, which is probably a lot of what you've seen. And the whole point behind having a machine like this is to actually build stuff. So we're going to see what that's like. I'm going to be building a cart for the Xlaserlab X1 Pro that can fit the machine. The wire feeder has places for all the cables and can roll around with my gas cylinder. So I'm really excited about it. Now, I've made 2 videos with this machine already, one where I did a deep dive overview and another where I compared it with MIG and TIG welding. So if you want to learn more about the process in general, I'll have those linked in the description. Let's get started. One thing I've learned so far is that fit up is really important. So I'm using the Evolution saw, which helps me to get a really nice clean fit up on my parts. And I'm just welding some 16 gauge square tubing, and I'll have a couple rectangles for the upper and lower tiers. Now the fit up you can see is really good, and so it's going to be ideal for laser welding. And as I get started, one of the challenges that I've found running a butt joint like this, like you have on the side of the tubing, is just tracking with it because it looks really different than it does when you're MIG or TIG welding. See, when you're MIG or TIG welding, you have a clear view of the weld puddle, but with laser, it's more of a macro big picture view, and so you need to get set up right, and you don't have that fillet to really guide your wire. And I found that a good measure of how well I hit the joint is the heat tint. Is it balanced? Do I see some on both sides? Right there, I think I'm biased a little bit to one side. And so that can help me, you know, just get better at learning. And with every joint, I did get a little bit better. And so, you know, there's definitely some amount of learning in how to set up for it. But right there, you can see it's balanced pretty good. And I was able to wrap over the start and end of the weld. And that's another challenge with this that I'm still learning, is how to tie those welds in at the end. Now, I didn't tack anything together, which I normally would have tacked this really well, but I just ran the welds and flipped it right over without grinding because those welds are so small. If I'd MIG welded this, I definitely would have ground it, but it's sitting really flat and the fit up's still really good on the other side. So that's a big time savings there, and maybe I wouldn't have needed to do that with MIG. It's just been how I've operated, but here I'll just finish this out, and I'm noticing that the power is dropping off on the laser welder, and notice how it's just sitting on top. Now that happened twice in this project, and what it was is the actual protective lens, and I think if I get my angle wrong and I shoot straight into something, it'll reflect back and burn that protective lens. Now I found some on Amazon that I'm going to give a try to, but they have them available also to just stock up. It did come with some extras, so I'm still good to go for the rest of this project just with what was included. And I think if I handle the gun right, it can go a really long time without that happening. Now, when I run these inside fillet welds, it's nice that this is a project where I can rearrange things. And those little fillet welds are just ideal for this machine, especially on the 16 gauge tubing. It's a perfect size, no spatter, no, post-processing required at all. And that's a great finish. Now for the outside corners, I was going to try to run them autogenous with this nozzle right here. But I realized really quickly that with those mitered corners, there's not a whole lot of material left, and so that's just really not going to work, and I need to feed some wire. So my options are to use the other nozzle that I was before, which I think would have worked fine, or you can use this nozzle that has guides for an outside corner and also a guide for the wire feed, and that worked really well. So I ended up going with that for all the outside corners. I think next time I'd probably just leave the setup alone and use the same one, but you can see here I started a little bit late there, so that's one of the challenges. Now I need to install some cross members into both of these upper tiers or into the lower and upper tier to retain the gas cylinder and create a handle. And this is really easy when you have those little grooves in the side for it to track. It's almost like a flare bevel groove weld, if you're familiar with that. And then on the side, you have the little fillet weld on the T-joint, and that worked out really well. Now, I did decide to grind these flat just a little bit before I put some tubing on, but it took a lot less time than it would with a MIG weld because there just wasn't much there. And I am set to go ahead and install these uprights to connect the lower and upper tiers. And at this point, I'm moving pretty quick with it, and the productivity is really high, so I like it. I like it really well. Now, after welding 3 sides, I might remove part of the fixture to get to this outside there. I needed to remove the square to weld the inside, and everything stayed nice and true. You'll see in a minute when I go to join the upper and lower tiers together that it's pretty much a perfect fit. Sometimes you have to do a little bit of wrestling around with this sort of thing if you don't build like a larger fixture, which it wouldn't make sense to do for a small project like this. But it really just set right on there, which is nice. And so I think there is a little bit less distortion than you get with some other processes, but there still was some welding distortion. I think the biggest limitation is really the ergonomics of the gun. See, I'm having to do a little bit of thinking about how to line up, and fortunately this project I can roll around and move into different positions, but if I were working on something that I couldn't, it would be pretty challenging in some cases to figure out what direction I want to point that gun, because there are some reflections and there's some stray light that can come off the end, so I never want it facing me. And you always have it in a drag angle, and so you've really got to think really carefully about that, and especially about safety with that stray laser light. Also, by the way, this is a different welding helmet than a standard one. You need a special welding helmet or glasses when you're working with lasers. Now, I have a really good fit up on these cross members. I always measure these after the fact in case it's up or down by a 16th or a 32nd of an inch to get it to fit. But this is a cross member just for a center shelf that's actually going to hold the machine, and the wire feeder will be on the top tier. Notice I rolled it around again to access the top of that joint, and if it were in a position I couldn't move it, I think TIG welding would be a little bit easier to manipulate around. But in this case, it's really nice. My design has several little detail sheet metal parts, and I wanted them cut nicely, so I ordered laser cut parts from Send Cut Send, and they showed up in just about a week. And this is a really good way to get these types of parts. They have sponsored several videos on the channel. This isn't a sponsored video by them, but you can find a discount code in the description that'll save you a little bit if you need those kind of parts. So these are cylinder mounts, and that circle and slot will hold some chain to retain the cylinder, and they're sized to be able to fit anywhere from an 80 cubic foot clear up to a 300 cubic foot cylinder, because I want to be able to put any size cylinder on this same cart. Now, these fillet welds are ideal for laser welding, and I think while the tube project is going well, small sheet metal projects or even large ones that have laser cut parts, maybe tab and slot design, are really an ideal fit. Just look how clean that is when you make those types of welds. Now, to add a little bit more rigidity and strength, I'm going to run an intermittent weld on the other side also that's actually offset from that first one. And this lays in really easily, so I can put a really long weld in there. The fillet welds are relatively small, but it's just attached to 16 gauge square tubing anyway, so you're not going to exceed the strength of that wall. And if you watch some of the other videos that I've made with this machine and tested the weld strength, I mean, I have a lot of confidence in the strength of these welds on this lighter gauge stuff. I mean, it just penetrates in really well and is a really robust, reliable process. So I've been pretty impressed so far, but I am new at it, so I am still learning exactly how to handle this thing and be the most productive that I can. Now, this little shelf is for a welding gun holder that I drew up, and I decided to run this, just a full-length fillet because I thought that would look nice on there, and it turned out great, pretty fast to do. I built this little fixture to build my hooks, which are just a little piece of square tubing along with a rectangular plate, and I found that I get bound up if I tried to wrap all the way around the corner there, so I did just touch the corner a little bit, but I am able to wrap corners. You have to move pretty quick to do it with that long gun, and that worked out really well, and you can get just a beautiful weld there, but you can also make one that's pretty ugly. So I had a stinker or two, but for the most part, the welds came out pretty nice. Now I'm going to attach those to the side of the cart, and I'll have 3 on one side and 2 on the other, which should be enough for every accessory that this machine has. And then I can just run some welds along the top and little fillets on the inside, and those will be good to go. Most of these welds turned out really good on the hooks, but it is possible to get one that looks pretty bad. And what happened here is I just wasn't lined up right and in a comfortable position, and so you can end up pointing the wrong direction, not moving like you need to, so you got to look out for that. There is some skill involved. So I had the holes tapped on these caster plates, and just a little tip for you, if you decide to do something like this, you need to drill out behind those. So I'll throw a little bit of sauce on there, and that always just helps everything to go a little bit better while I drill it. And then use a step drill, and that's nice because it'll deburr my hole, and I'm ready to weld these on. And I have a little, almost like a flare bevel groove weld there that I can track along with, and my wire will just sit right in that edge between the two, and I'll weld these on all the way along both sides, and then put a fillet weld on the inside also to hold them really well. Now see how that wire got stuck? Every now and again, if I don't handle the gun just right at the end, it'll get stuck. It's kind of a nuisance. Now I'm using the cutting feature here, and I've switched over. All of the welding I'm doing with argon because that's what I have. But I've switched over to high pressure compressed air, about 90 psi, and that's working really well to cut this. Now, it's a little bit of a different feel than a plasma cutter or a cutting torch that I'm used to, and so I'm just kind of getting the hang of it here, but it is working really well, and it cuts right through, so that's nice. But you got to be pretty careful with what's on the backside because that beam is shooting out past it much more than you'd have with a plasma cutter or something like that, so proceed with caution on that. I did find it a little bit more challenging to read the cut speed. You can see I get some sparks bouncing up if I go too fast, but I'm not able to watch underneath to see the angle that they're coming down from, so it's a little harder to tell. But once you get the hang of it, it works pretty good. And that kerf, look how small that is. That's a pretty unique setup there to have just that tiny little kerf when I'm cutting some pieces. These are just some notches to be able to clear that tubing on the lower and middle tiers. Now, when it comes to cleanup, there is a little bit of dross or burr on here, but it doesn't take too much to clean up. That's all it took to knock all of it off that edge. And you can see how nice the little welds are. I just put some intermittent welds around to hold it on, and there's basically no cleanup at all. Now for the axle, if I were MIG welding it, I'd just put a big old fat weld right in there on the bottom and call it a day. But since I knew I was going to laser weld this, I designed some little plates for the side. So you can design your project around the process you're going to use. And I got some nice little fillet welds on the inside and also on the outside, and it gives a good clean look. And I just have some holes drilled in it to use cotter pins to retain it. We'll put that on in a minute. Now I threw some paint on there, and I'm just going to torque these front wheels to spec and add that cotter pin on the back. Now I went with some larger casters and wheels. I've never wished I had a smaller wheel on a cart, that's for sure. Now here's the finished product before I loaded it up with the machine. I wanted somewhere to store my gun, so I designed this cradle that I could remove and put on the cart. I just put some cup magnets here on the bottom so I can set it on my welding table or even on a project, and then add it on the welding cart to hold the gun while I'm storing it. This also leaves a little extra room for that fiber optic cable. Now I have dual chains to hold the gas cylinder in place so it can't tip over on me. And then on the other side, I have a hook for the wire feeder, the work clamp, the e-stop button, and all of those accessories that I might need. And so this puts the whole thing in an all-in-one package that I can roll around and actually use. So it's a pretty cool project. Well, the cart turned out great, but that isn't the point of the video. I'm really trying to get a feel for what it's like using a laser welder for an actual fabrication project. And I will say it's a little bit more challenging than it is to run coupons on the bench, right? When you go to trade shows and they have these demos set up and it's all dialed in and it just stitch right along a joint, that's one thing. But when you're working in different welding positions, different types of joints, imperfect fit up, it can be a little bit more challenging. And by the end of the project, I had a pretty good feel for how to hold the gun, how to get set up, how much pressure to apply on the wire to get it to feed right, and those sorts of things. And they were turning out consistently really good. So if I were to build another one of these carts and I had my option of processes, I'd reach for the laser pretty much every time if I could. So definitely going to be a useful tool in the shop. If you want to check out one of these Xlaserlabs X1 Pro machines, I have a link in the description. It's an affiliate link that does help support the channel, and be sure to check there for any current discount codes as well. Be sure to let me know if you have any questions in the comments or any thoughts on this video. And if you enjoyed this or learned something, let me know by hitting that thumbs up below. We'll see you next time.
Such a fun video for me to record. You're watching me unbox an Xlaserlab X1 Pro laser welder. The good people at Xlaserlab sent me this absolutely glorious machine. They heard about my upcoming projects, like the Aurelia supercar project, and they wanted to help out. They wanted to be a part of this, so they sent me this machine, and I'm super grateful. The box came with a bunch of extra goodies like gloves and all sorts of consumables, etc. You'll see me open them here. Here's a mask. Especially when doing stainless steel, you want to be using something like that. This is the wire feed itself, separate from the unit, unlike a MIG, which would have it integrated into the unit. And it comes with 4 drive wheels. There's 2 additional in the back for different size wire. And finally the big box, which Customs didn't even open, by the way. And some laser safe glasses. This is like a ground. I'm not even sure what that is. A lot of stuff in here. I'm still not sure what it all is. This is like a little test piece that they provided to show the machine worked. Beautiful little welds. This is steel. Sorry this footage is a little bit blurry too. I fix it as we move forward in the video. I apologize. Little safety switch. These I think are like replacement lenses or something. To read the instructions exactly how they're consumables that need to be you know, used and replaced every so often, but I'm not sure how often. And this little box here, this little tin has nozzles, different nozzles in it. I just used the nozzle that it came with. I didn't even switch it out for all the stuff you see me do in this video. More consumables, some sort of lenses or something. I didn't even open them. Here's the gun portion itself. A little different than MIG or TIG, but you know, pretty straightforward. And by the way, the packaging, whoever packaged these needs a raise, because I've never seen such perfect packaging for anything I've ever purchased. Here's all the stuff that came with the kit. Lots and lots and lots of things. And of course the instruction manual, which I'll have to read.
So as you can see, this is a lot more complicated than your standard MIG or TIG setup. Before I get started explaining what this stuff is, I had to get this adapter. The plug that comes with the unit, at least mine, had one of the prongs is horizontal and not vertical, like 2 verticals. And I didn't have that plug in the shop. So I bought the stuff to have my brother install it in the shop. And it turned out that I bought one of these and I needed to buy one of these. And so when we were figuring out that that wasn't going to work and I had to buy new parts, I saw on the back of the welder it says 220 on it, not 110. So I wrote to the company and they told me that I could use my 220 outlet that I already have in the shop for my TIG. And so I had to buy this adapter, and this adapter is basically for the 220 outlet to whatever they call that outlet, with the horizontal prongs. So if you guys need this, I will have a link to Amazon in the description below the video so you guys can pick one of these up. I think it's 20 bucks. Okay, so you have the unit itself, you have the wire feed, which is separate, unlike a MIG. You have this safety switch, which is actually magnetic, which is kind of cool. There's also a safety switch on the front of it here, you can see. There is the gun itself with the wire feed coming up to the end of it. And this is, it's a ground, sort of. It's not really a ground, it's basically like a safety switch. So you don't need ground, obviously, if you're using a laser to be doing the welding, but it does function as a ground. So that's where we stand with all this stuff. That's why all these wires are everywhere. I'm going to try to get this out of the way so we can just have a clear open area here. I need to set up a more appropriate welding area, actually. This is what I have right now, but we will be upgrading the shop when we move to a new shop, and it'll be a proper welding area. Anyway, let's get this thing set up, and let's get started doing a demonstration.
So let's first go over the controls of this thing. You have 3 different settings: welding, cutting, and cleaning, and you just confirm whatever setting you want. There are lots of metals already in here for different thicknesses, and it'll kind of adjust it for you. The metals, you have to kind of look those up, because I'm not sure what most of those are. Aluminum, obviously, AL, and your thickness over here, and then just confirm. And you can change all these different parameters too. You don't have to leave it at what it is. You're gonna have to make sure to turn the wire feed on. For some reason it turns itself off a lot, but make sure that's on. And this is how you power it on. When you do that, you'll get a confirmation here that you're wearing glasses. Click that, and then don't forget, turn it back on after that. When it lights up green, it's on. I always turn it off to be safe. And you can change these parameters too to suit your needs. Now back to mode selection, we'll go to cutting. I did not use cutting in this video. You need compressed air, I think, to be able to do this. But you do have the option to do that. And these are your parameters you can set. And then the last setting is cleaning, which is like rust removal or even paint removal. And here are your parameters you can set for that. Pretty straightforward. Back to welding. Okay, so I did some testing for, well, first of all, make sure to wear your safety goggles. This is extremely important. I did some testing, and I was actually had a problem with the wire feed because of the wire I chose. So this is my first, actually second test weld, test bead that I put down. This is on 3mm or 1/8 inch aluminum, and it's beautiful, and it was so easy to do. Here you can see it up close. And if you flip it over, you can see the problems I was having are just causing me all kinds of issues. But I used thicker wire, and it solved the issues just fine. Here's my first real weld on 1/8 inch aluminum. And as you can see, it'll jump around a little bit, and you gotta keep it straight. You can see I came off track there at the end, and that comes into play a little later on with the strength when I test it. I did both sides. And it's not like MIG or TIG. You don't hover, you actually touch the wire to the part, and then the wire pushes you along at the proper speed. So it's very easy to do this. you can see, they're very nice welds. Except for there, but that's my fault. It's a little hard to get used to not hovering. So here I'm testing. You can already see on the right hand side there, the end of that weld is not quite secure. That's my fault for welding off center. But where the weld is holding, you can see that even the metal is deforming pretty greatly, and the weld itself is holding 100%. I mean, that's very impressive. And I tried to give it a little extra. This is all the 3mm or 1/8 inch stuff that I had, so I can't get really good leverage on this thing. But it's the biggest I had on hand. But as you can see, I mean, this is very, very strong stuff here. These videos where laser welders are not welding stuff, they're just not using the tool properly. Because if you do it right, it holds perfectly. This is what I'm really interested in. This is 63 thousandths aluminum, and this one actually I messed up on. You can see I went out of track multiple times, so I didn't get very good welds on it. It welded fine, but it was me that was not welding straight, so it was giving me issues here. But this is what I'm going to be welding mostly, which is why I was so interested in having a laser welder. Because TIG welding, thin aluminum, if you guys have done any of that, oof, what a nightmare. But this is just a pure joy. I got a really good weld on this one. I practiced a couple times, and you can see I've got a weld across the entire piece here. And I'm just going to put a wrench on it, bend on it some. And as you can see, it's a solid piece now. Now it does break. I broke it on purpose to see where it would break, and it breaks beyond the weld, so it's actually snapping beyond where the weld is. And I'm really cranking on this too. It's pretty stiff stuff. As you can see, it broke outside of the weld, so the weld held just fine. I got a little bit of a close-up here, as you can see. The weld is perfect, and it broke outside of the weld, which is pretty much to be expected. Here I'm using 1/8 inch steel plate. This is my first time using steel. This is 30 thousandths wire. You can run 30 thousandths wire in steel, but you can't do that in aluminum because it will not feed properly. So you can use the thinner wire for steel. I just followed the little trench, and I didn't even weld the backside of this. You can see I flip it over here in a second. You can actually I'm just looking at the weld, examining it, and look at the backside, and it's almost a complete weld on the back as well, which I did not expect. I thought that it would be a real problem, and I'd have to do both sides. Now in the real world I probably would do both sides just to be sure, but that worked out really well. This is just some metal I had laying around. It's from TV stand or a TV mount, and this blew me away the way this looked. I mean, I am like, this is I was stunned at how amazing this weld was. It is so perfect and so clean and so easy, and it took, I mean, you saw it was like 1 second of welding. I mean, it would almost be a shame to like dress the bead and like grind it down. Like, I want people to see that instead of hiding it. It's incredible. And you can also do some laser cleaning. You can do cutting as well. I didn't do that, but the laser cleaning is very easy, and what a handy little tool this is. This is all included with the kit. You can see like it just burns through that rust. You can ignore those ugly old welds from my early MIG welding days. Here's I don't even know what this thing is, but it's a big, ugly, rusty part that I found, and I wanted to see what it would do. Now, it kind of scared me because it was a little loud, all these sparks and everything flying, but yeah, it works great. It's just like it's like sandblasting, but with laser light. And it's pretty easy, and I can imagine this being very, very, very handy for people to use, especially if you're a mechanic or something, and you know, you got a lot of stuff to clean up. Boy, this is the way to do it. And while I was at it, I was thinking, you know what? I wonder if this thing can burn paint off too. So I got that thing I just welded up, and it's got some kind of paint on it. I just want to see if it would take it off of there. And I shouldn't have been shocked, because of course it does. And it works super easy. Look at this. I mean, that's like, what an amazing feature this thing has. Super cool.
Okay, overall impressions for the Xlaserlab X1 Pro welding machine. I could not be happier. This thing is everything I imagined it would be, plus. It's my favorite tool now in the shop. If you pick one up, I'm sure it'll be your favorite tool as well. There'll be a link in the description for more information on how to get one of these. The welds are incredible. I'm not really much of a MIG or TIG welder. I mean, I do the job. I mean, you know, I'm not a professional welder by any means. But this makes me look like a professional. I mean, I am far more proficient with this, even after years of doing MIG and TIG work. I'm just blown away. Plus the cutting feature, which I did not use, and the laser cleaning feature, I mean, those are, I mean, it's just, it's an incredible machine. The welds speak for themselves. You saw the pictures in the videos. A couple of things that I wish were a little bit different. I had some issues with the wire diameter in aluminum. I bought 30 thousandths thinking that it were 0.8 millimeter, thinking that it would work. And it was too thin to feed into the machine. Now, so I talked to the company, and they walked me through it and told me that I needed thicker wire. It was just as simple as that. But none of that stuff is in instructions. Most of the stuff in instructions is just about safety. They don't really show you all that much how to actually operate the machine. I wish the instructions were a little bit more clear. Most of that stuff is safety, and it's like, it made me afraid of the welder, to be honest. At first I was afraid of it, thinking that it was going to blind me or catch something on fire. It's not as dangerous as it really seems. I mean, it is dangerous, don't get the wrong idea, but it is perfectly usable in a home shop. There's no issues with that. I'm very comfortable with it now, as comfortable as I am with any other welding. Another problem that I noticed was the glasses are green. I imagine that all of the laser glasses are going to be green like this. And the controls, a lot of the lights on the board are also green. So it's sometimes more difficult to see if it's on or not. And so you have to constantly take your glasses off to make sure that it is off when you want it to be off and on when you want it to be on. Another thing, I don't know why, but it forces you to turn the wire feed on all the time. So if you forget to turn it on, it'll weld a lot like what you saw me do in the beginning of the video, where the laser will melt the metal, but there's no additional wire added. I'm not sure why it turns itself off like that. Also, the metals are labeled in a really weird way, so you have to kind of look them up to see what kind of metals they are. Maybe you guys are experts, I don't know, but I certainly was confused by it. I understood aluminum, but the rest of them I had to kind of look up to see what they meant. The gun, I don't know if this is necessary for safety or something, but and I'm sure you can't see this very well, but there's two triggers here. I didn't use the top trigger. That's just to change the settings or something. I didn't use that at all. But the bottom
trigger button, the actual action button for the welder, is just a simple button. And when you're wearing gloves, it's hard to know that you're on the button. It's hard to feel where that button is. And I was constantly like looking for it as I was using it. I would prefer it to be more like a MIG trigger, like a traditional trigger, like a MIG machine would have. I think that would be better. I think especially because you need to be sure that you're not tripping it accidentally. And so maybe that's a safety thing though. I don't know, I'm not sure. But all of those things said, I can work around all that stuff. You know what I mean? It's not, those are not, you know, deal breakers by any stretch. I'm completely blown away by it. It's way better than I thought it would be, and I was pretty impressed seeing a couple videos on it before I actually got this thing. I couldn't be more impressed. It's amazing. It's my favorite tool, and I can't recommend it highly enough. If you're thinking about buying one, stop thinking about it and go do it. There's a link in the description below, so you can go check it out and learn about it. Yeah, A+, guys. I can't say enough good stuff about it. I'm very happy. So anyway, I will see you guys in the next video. The Aurelius project is coming up. I actually have a couple of other projects specifically for this Laser Welder 2 coming up. I've got another Rocketeer jetpack build, and I'm going to do a couple of mask commissions too, and I'll show you how this thing works on a real project, not just little practice sheets. Anyway, that's it for me. See you guys later. Like, share, and subscribe.
Sweet. This isn't fun anymore. That's painful. I think that's enough adventuring for today. I haven't ridden a bike in over 20 years, let alone an e-bike. So when I was offered one to try out, I was intrigued to see how well this tech performs. Well, let me take you on a ride. So here's the thing, and my honest answer, it kind of sucks. But don't get me wrong, I'm not actually talking about the bike itself. The bike is awesome. As you can see, it's taken me up this hill and I'm not even pedaling. No, what actually sucks are British laws. I'll stop here just so you can hear me. No, an e-bike's limited by law to 15.5 miles an hour. And if I'm honest, I can understand that. That's an absolutely sensible law, because over that speed, these kind of things get dangerous. No, it's not that. It's the other laws surrounding it. So the motor is limited to 250 watts. And that limitation is across the board, no matter what e-bike you get. So there's no point spending huge amounts of money, it seems. Fortunately though, with the Cyrus Ranger, the motor actually can produce 750 watts. And technically it's unlawful, but you can unlock its power. But here's the thing, you want to unlock its power if you're a little bit heavier and you want to get up a hill. And personally, being a non-cyclist, I don't want to have to wear Lycra to get the best potential out of my bike. So I've actually come up with an idea that gets me around the law and enables this bike to be actually quite useful. First of all, let me show you what else I've made illegal on this bike. So I added a twist grip, which is completely illegal. Also thumb accelerators, highly illegal. However, that's going to become very useful shortly. And the assisted speed limit goes up to 30 miles an hour now. What I did is I added an unsuspicious button just down here. So if you have a quick peek inside, that button is linked to these two wires here. If I disconnect that, these two wires, when connected, is the limiter. That's now restricted to 15.5 miles an hour. So just to be clear, I intend to use this legally on the road. Hence why I've added a button, so I can switch between illegal to legal. And I'll be doing the same for my twist grip and thumb drive. This will be disconnected and the key removed, and the twist grip will just have its cable pulled. Another irritation with the law is I can't ride this on public footpaths. So for legal use, I'm restricted to roads and bridleways only. That is, unless I have permission to ride this on private land. So you might be thinking, if the rules suck so much, what are the benefits of having an e-bike? Well, let's just say, hypothetically, you arrived in the UK on a small rubber dinghy, just to find you'd accidentally dropped all your credentials into the ocean. Well, an e-bike is certainly better than a regular bicycle, and you don't need a license for it. But let's say you could get a license, surely having a regular motorbike is better. But one of the best aspects for going electric is it's almost free to run. That's if you've got one of those fancy solar charge inverters, or we can charge it at night and get a nighttime tariff. In the meantime, I want to make this bike actually useful, so let's do some R&D. So I came up with a really simple flatbed trailer design. Underneath we've got hidden compartments for all the electronics, but to do something a bit more interesting, I've also created a camping module. This will be welded out of aluminium, and I'll use the laser welder for that. And I am not